Welcome everybody. In these videos we're going to be demonstrating GitLab CI/CD. We're going to take some code, it's a Spring Boot microservice, we're going to build it with GitLab's pipelines, we're going to build a Docker image, we're going to push that image into GitLab's container registry, and then ultimately we'll use the same pipeline to deploy our code onto Azure Kubernetes Service, AKS. So let's clone our repository and get started. So I just copied the link to the project from the GitLab page. So I'm going to make a new directory, change into it, clone with Git, and then take a look at some of the files that are in the directory. You can see a ready-made Docker file, the README, a Vagrant file for those that want to use Vagrant. There's a build with Gradle, the documentation, the Gradle wrapper, some Kubernetes files which we'll come to later on, and the source, which is where our Java lives, plus some additional Terraform modules that we'll use to spin up our Kubernetes cluster on Azure. So before we go any further, let's just check that our code builds. We'll use the Gradle wrapper, build, and daemon gets started, and a few seconds later we'll see that it's built successfully. So that's great. So let's try and run our code. So Spring Boot, so we can use the Gradle boot run task. And we see that run as well. So we see the familiar Spring logo and Tomcat started on port 8080. Let's just open up a second terminal here and we'll try and hit that endpoint on 8080 with curl and just prove that our application is alive. And there we see it. Hello world, I've just been deployed by GitLab, a little prematurely. So I'm now in my integrated development environment, my IDE, IntelliJ, and you can see I just have a really simple application, just two classes. The first is the application, where we declare our Spring Boot app and run it. Simple as that. And then the second is our controller, where we respond to HTTP requests here on the root path. And if we get a request, we respond with a really simple message, hello world. That's the message that you saw earlier. And I don't want to focus on it too much in this video because we're talking about CI/CD rather than programming, but here's also the Gradle file that we used earlier to build our app. You can see we declare our dependencies and the version of Java that we want to use and how to compile it, just to show you how the magic happened earlier on. The next thing that we want to do is put this code into a container so that we can run it on Kubernetes later. Here's a Docker file that I've written earlier, and you can see that it's fairly short and just contains a few arguments. Firstly, the project directory. This is where our code is going to live inside the container. Adding that as a variable, an argument, arg, just makes the container a little bit more flexible at build time. Secondly, we use the from argument to indicate the base image that we want to use, that we want to build our code on top of. And here I'm using the Alpine Linux distribution, which is a very lightweight Linux distribution that keeps your images nice and small. And I'm picking an Alpine distribution that has had JRE ladled on top so that we can run a Java application as the Java executable. There are a couple of different ways to get our code into the container, and the add keyword is one of them. There's also the option to copy, and they're similar but subtly different. You can see that we find our AKS accelerator jar landing in the project dir build libs AKS accelerator.jar location. And this is a little bit like the copy command in Unix. We're going to copy it from that location to a file called app.jar, and that's where we'll find it inside the container when we come to run it. And that's what entry point does. That tells the runtime how to execute the code within our container. And you can see that it uses a JSON array as a syntax, which is perhaps a little bit strange the first time you see it, but the command should be no surprise. This is what you do with Spring Boot. It's java -jar and the name of our jar to run it. After constructing our Docker file, the next thing we want to do is use docker build to build our image. You can see here we specify dot to indicate that the Docker file is in the current directory, and also the -t for tag flag, where we can specify a name and a tag, effectively a version for our image, and then we can see it build. You see it step through each of the layers. Docker uses a layered file system concept, so individual layers can change and only those layers need to be replaced rather than the entire file system. We can then call Docker images to see the built images that we have on our system, and I'll just take the top 2 rows here, and you can see that it's just built just recently and that it comes in at a very respectable 100 megabytes. We have a lot of resources to create, so we'll use Terraform. Make an Active Directory Service Principal, resource group, storage account with log analytics, AKS itself, and a virtual network. The first thing that we ask Terraform to do is init, which will download any providers and modules that we need to actually implement our infrastructure. As part of the creation of the cluster, we need to give AKS a service principal so that it can interact with Azure and make resources like VMs and load balancers and so on. So we'll just use the command line to create a little file called secrets.tfvars. The name isn't important. We'll use the OpenSSL rand function to give us a random password, and then we'll pass that into Terraform. And before we actually go and create any infrastructure, we'll call Terraform plan, which is a bit like a dry run. So we can just see what we'll be creating if we go ahead and actually call apply. And then here's our plan. We can see what Terraform would actually build if we were to ask it to. It's going to build 14 resources, which are the things we expect. So let's go ahead and kick it off. And the syntax that we use for creating the infrastructure for real is very similar, just apply instead of plan, passing in that secrets file. We can see the resources that it's going to create. It gives us the opportunity to confirm. We type yes, and then off it goes. And it took about 9 minutes to complete. And for a bit of a break from the command line, here's a view of the portal after Terraform's finished. So you can see the resource groups that we've created for Kubernetes itself, for the network, and the managed resource group that's created by the cluster. You can see the Kubernetes service in here with the name that we chose, and the log analytics. The workspace has been created for us. No load balancers yet, and then of course we've got a virtual network where the cluster will live. Back in the command line then, so we can use the AKS options to see the cluster. So we can list in the form of a table. We can see the cluster's name, location, resource group, and FQDN, the API server. So let's get the credentials for it, and Azure provides a nice helper function for that too. So that will, if we pass in the name of the cluster and the name of our resource group, it will pull down the credentials we need from Kubernetes and insert them into our local kube config file and set the current context. It's very nice. So we can look at the cluster and see its details. We can see the masters running, we can see the API servers running and our HTTP routing add-ons. If we get nodes, we'll see the VMs that we've got running. We picked a 3-node cluster, each running Kubernetes version 1.12.6. So we're almost at the end of our setup phase now. And the final thing we need to do is just get the details that GitLab will need when we try to connect GitLab to Kubernetes. So first thing that we want is the CA certificate associated with our default service account. So we're just going to use kubectl get secrets to grab the name of the default token and then just extract it from the config map as a fairly familiar looking PEM format certificate. So we'll copy that for later. Next, we need to create a service account for GitLab itself. So we'll do that by applying a YAML file that we've created already, which just creates a service account called GitLab admin. Here's the YAML, GitLab admin service account. So we'll create that, and then we will give that the cluster admin role via a cluster role binding. And then finally, we can get the token that is associated with the admin service account. With that done, we have all the information we need to ask GitLab to talk to Kubernetes. So let's hit Add Kubernetes Cluster and fill in the details we want. Now, we want to add a new cluster because we're not using GKE. So we know the cluster name. We can paste it in, AKS Accelerator AKS. And we're going to set the environment scope to staging because we're going to use this as an environment for continuous testing. And we know our API URL. Remember to put the HTTPS in front. And the certificate was the first thing we grabbed, so we can paste that in. And also the token. of which you can see some here. So we click Add Kubernetes Cluster, and the configuration's done. And then the first thing we need to do is install Tiller, which is the server-side component of Helm. If you're not familiar with Helm, it's effectively a package manager for Kubernetes. It lets us install complicated applications very quickly with a single artifact that they call a chart. So let's give that a second to install. And that's done. So now that Tiller is installed, we can install Gitlab Runner using Helm. Gitlab Runner is the component that GitLab uses to really talk to the cluster, so to run CI/CD, to deploy applications and manage them for you, and so on. So again, let's give that a second to install. So now that we have Gitlab Runner, we can go and create our first pipeline. So we have a GitLab CI file in this project already, so let's click Run Pipeline and click Create. And we can see the stages that we defined in our GitLab CI file: build code, build image, and deploy. So if we leave that to run for a second, hopefully we will see it go green and our application will be in the cluster. Unfortunately, nothing's that easy, and this didn't quite work first time. You can see the first attempt failed, and that is simply because I'd hard-coded the name of the repository in the GitLab CI file, and this project we're using here is a fork. I did that just so we had a clean slate. So I fixed that and ran it again. It looks like we have a second problem, which is a permission thing. So we can fix that too with kubectl. So let's go to the command line and apply the permissions we need, and then try one more time. In the Kubernetes directory in this file, we have this template that will apply the cluster admin role to the AKS accelerator. Insert your name here, service account. So we can edit that file and paste, instead of the X's, we'll replace with the specific namespace that GitLab has generated for us. So let's do that. So we have that admin account, apply it, and then we're ready to try it again and see if our pipeline works third time lucky. The previous error told us that GitLab was trying to deploy into the namespace it had created just for our application. So I just had to change that in our GitLab CI file. Again, it was hard-coded to the previous value. Once I did that, the pipeline went green. So let's have a look at the IP that's been assigned to our project, and then we'll be able to check it in our browser. And we see we've got this 137 address, which is public, so we can curl it, and there's our application. So before we finish, let's just make one quick code change and see the whole thing run through end to end and prove we've got full continuous deployment. And just to mix things up a bit, let's use the cloud editor for that. We'll just change the message, give it a commit message. Save the changes, and then let's go back and have a look at the pipelines. We can see that they're running. So let's watch, and hopefully we'll see it go green, and then we'll check the application again. I've accelerated it for the purposes of the video. It's a bit boring to watch otherwise. It usually takes 2 or 3 minutes. It's gone green, and we know our IP address from the last time that we called it from the command line. It's still in my clipboard history here. So let's just hit it in our browser for a change and see if we see the new message. And we do. Continuous deployment is great, and I hope you agree that it is. Thanks for watching.